Okay, you can all see the screen. First job, I want to go over some of this. At least one of you wants me to go over this, so I'm going to go through it quite quickly. Please bear in mind, I upload this to YouTube, and if I'm quick enough, I can get it into the existing lesson title. Now, we did exponential graphs a little while ago. They're all marked up and sent back to you, obviously. However, there's a small window of opportunity to get the video up, edit it, and get it to you. So I usually have to start another whole homework just to say our video from the lesson. So I'm going to do that again, which means I can go quite quickly, although I will take questions. And also you can view it at your own leisure and just stop the video and take what notes you can. So this is the first example. You can all plot y equals 3 to the power of x. This is me doing it without a calculator. You can all plot y equals 2 to the power of negative x, so it sort of accelerates it the other way like that, which is beautiful. Again, this is me working it out manually. The next one is the first of the grade A questions, otherwise known as grade 7, and it's the first one where they want you to do something other than just plot the thing. So yeah, B, plot it, good. Now I don't want to see answers down there without any evidencing, all right? I need to see arrows. So for example, again, find the value of x when y equals 1.5. Sorry, find the value of y, so that's my dyslexia, find the value of y when x equals 1.5. So here's my x, 1.5. Hit my line, turn left, bang, that's about 9 on my graph. I don't mind what it is on yours, as long as you evidence it. Find the value of x when y equals 11. Go up to 11, which is 2 squares above the 10, turn right, hit your graph and your curve, and then come down. Mine is about 1.6. I think, or 1.7, I can't tell, it's too dark, so, or too light even. So 1.6, it doesn't matter, I've evidenced it on my graph, it's right. For my particular, the way I drew the curve freehand, not everyone's going to be exactly the same. But unless I see that, I'm suspicious of that, or you're being naughty. Next one, another negative graph, negative power graph, so it's going to really take off quite quickly because it's 3 powered up, not 2 powered up. Again, many of you showed me the evidence for this one, which is wonderful. So solve 3 to the power of minus x equals 7. In other words, I've already got the line y equals 3 to the power of negative x. I just want to draw in the line y equals 7. And there she is. I'd have to draw it right across here. It's a bit lame because my graph is over this side. So I want to use my line y equals 7, hit my graph, come down, and my one read as minus 1.8, something like that. That's all it is. Now, I want to teach on this. Yeah, many of you had a good idea of what's going on with this, but I want to teach as to why it's like that. So I'll put the answers up against my actual branches. So D is y equals, oh, Alexa, where's she been? Of course. Okay, she's missed this. So I want to, I wrote my answers next to the actual graph. So y equals 3 to the power of x is that one. Y equals 5 to the power of x is that one. Y equals a quarter to the power of x is that one. And y equals 2 to the power of minus x is that one. Why does this make perfect sense? Or maybe it doesn't. Well, consider this for the moment. I want to use this line facility here, which my graphics pen can't do. So I'm going to have to go really, I wonder if it can actually. Let's try it. No, it didn't do it at all. Let me just rub it out. Rub it out, yeah. Rubber! Okay, is there a reason why you're not rubbing out? Pen, rubber. Okay, I've completely crashed on that. I don't really understand why we let you do the rubber. I've got to find out how to do this. Oh yeah, that rubber. Okay, I've got several different things open now. I've got to go freehand, guys, so just watch this, bear with me. Right, I've got my rubber now, back to pencil. So watch this. I've got to try and draw it freehand, it's a real pain, but here we go. Look at this. I'm going to assume x equals 3 and draw the best straight line I possibly can with a wonky, that's awful. You know, I actually do deserve to be laughed at this point. So you feel free to unmute yourself and mock me all you want, because I actually do deserve it. I can't draw a straight line on this graphics tablet. Let's try. 3. Right, here are two solutions. Again, this is really, really crude. Do you know when x equals 3, y becomes 3 to the power of 3? Anybody know what 3 to the power of 3 is? 27. Look, that's quite close. Now, what about this one? Y equals 5 to the power of x. Does anyone know what 5 to the power of 3 is? Yes, it's called 125. So do you see, for the same x value, 3 to the power of 3 doesn't go as far up as 5 to the power of 3. Now, of course, that should be bang on, you know, roughly 125 based upon the maths. But you see, for the same x value, the graph with the bigger value before you power up accelerates really quickly, so to speak, which is why that has to be 5 to the power of x as opposed to 3 to the power of x. This looks really cryptic until you realize actually a quarter is the same as 4 to the power of minus 1. Okay, 4 to the power of minus 1. In other words, 4 to the power of negative x. So these are identical. Now, based on what I've just said with that one and that one, you can see that 4 powered up will be much steeper than 2 powered up. Does that make sense? And I could give an example again by using minus 3, and I suppose I could do that because I need to practice drawing skills. There you go. That's there, and that's about there. So I'm going to use my minus 3 for this one. Great. So here I've got 2 to the power of minus 3, which is 2 to the power of 8. 2 to the power of positive 3, which is 8. So this should actually end up being on 8, which is just below 10 from my rough sketch. Now, what about this one using minus 3 and this graph here? Well, I've got 4 to the power of minus 3, minus 3 is plus 3, and of course 4 to the power of 3 is 64, which is why it's way up there, not 74, 64, but it's, you know, it's really crude. Maybe it's about here somewhere because of where I've drawn it, but that's the principle. You can test things out, and that's what I was doing over here. Look, minus 3 becomes 2 to the power of 3, which is 8, which is sort of what I'm doing there, and that is my thinking behind that. Again, this is going to go on YouTube. It's going to be okay-ish. Now, okay, so some of you just went 5 rabbits, 320 rabbits, 10 years. No, you don't get marks for that at GCSE because there's no working involved, and you could have just guessed. If this was, say, if part C was, for example, a 3 marker, you get 1 for the answer because they'll assume you've done it right, but they can't know. You get 1 for the answer. Now look at this. Here's the formula. The number of rabbits is 5 times 2 to the power of y. Y is the number of years. How many rabbits initially? In other words, in year 0. So n equals 5 times 2 to the power of 0, and 2 to the power of 0, you know, is 1. And 5 times 1 is 5 rabbits. Ditto for 6 years. 5 times 2 to the power of 6, 320 rabbits. Not difficult, but show your steps. I was really not happy that some of you just wrote down 10 years, expect me to put a tick on it. No, don't expect anything. Let me show you what I did, because I'm a complete genius. I thought, I don't know how to get to 5,000 rabbits or just above, so I went for 20 years. And I ended up with, after 20 years, I ended up with 5,242,880 rabbits, which is a bit bigger than 5,000. So I thought, bad move, but it's trial and improvement. They're not going to get it in one step. So and then I thought, well, let's go for 10 years. I thought, I'm always bang on. Now, after you try a 10-year trial, don't assume that a power of 9 years, would give you a number so much smaller. You don't know unless you try it. It's called trial and improvement. So knowing I was really close, I had to trial 2 to the power of 9 times 5. It wouldn't make any sense to go 2 to the power of 11 because I know I would be above 5,000 by even more than the 120 I see there. So I did 3 trials and got it. Now I get all my marks. Trialed it, shown what I've done, adjusted my answers, and concluded just above 5,000 is going to be 10 years. This is the bit many of you wanted help on. By the way, this isn't completely wrong, it's just messy, and I didn't like what I've done. So you're given 2 points and they're sitting on this line that's completely bland and there's no numbers in it. I know there's a y, I know there's an x, which means I can use the coordinates to try and find m and n separately. Well, let's do the easy one first. It's really easy. Yeah, okay. Well, 25 is the y and the 0 is the x. So I'm going to put my numbers there and get this. And I know anything to the power of 0 is 1. So m is going to be 25. That's quite easy, 2 marks, I would say. And I don't need to write this, but I do need it for the next step, of course. So I know the equation is partially finished. It's y equals 25n powered up to x. So my m is no longer a mystery. It's worth 25. Now, I'm going to try and make it fit here, I think. Maybe when it says PTO, that means I got it wrong. Let's turn over the page and do it properly. So here it is. Yeah, I know y equals 25 times n to the power of x. I'm going to use the other coordinate because the other one won't give me any more information. The other one gives me m equals 25. This one is going to give me much more. So, okay, so that's my x value. You're going to go right there. You're the y value. You're going to go right there. And I'm going to get this. 100 equals 25 times n squared. N squared is 4. Y, because I'm just dividing by 25. And this graphic tablet can't do dots. So square root it, n equals 2. Finished. Done. Watch the video. Meditate on it. This is tricky. A star, in other words, grade 8, maybe a bit more. There's a number of ways of doing this. I know I've got to use this. I know I've got to use that. In exactly the same way, I had to use 2 coordinates to find the 2 unknowns in question 5. In the same way, I've got to use the 2 coordinates to find the 2 unknowns in question 6. Well, let's just do the easy one first. Now, if I use the 1 and the 5 is my y and the 1 is the x. Well, so therefore I've got 5 equals p times q powered up to 1. That's no great help. I don't know what p is. I don't know what q is. I just know that p times q is 5. Well, it's a start. I've got to move on. I can't do anything else with it. Next one. I know that y equals p times q to the power of x. Using this coordinate, 320 equals p times q to the power of 4. And when I marked this work from some of you, I said, set up 2 equations with p. Set up 2 equations with p. And hopefully that was a hint to some of you. If not, obviously you've got to ask your dad. And then when your dad tells you path, you tell everyone else, and everyone's really happy. So no one's left in the dark. But let me teach you anyway. So these are the 2 equations I have things to do with. I've got u and I've got u. And I sort of wrote this in the form of p equals, and I wrote this in the form of p equals. Here, there's an even easier way of setting this up. Now, I'll work down here because it's tidier actually. I have got 5 equals pq, is that right? Somebody confirm that? Because I'm having to do it from memory. Yeah, I've got you. And I've got 320 equals pq to the power of 4. All right. And I've got 320 equals pq to the power of 4. And of course, the q there is a power of 1, but you don't need to write down the 1. And then I thought, wait a minute, what if I do this? And this is really simple. 320 divided by 5 is exactly the same as writing p times q to the power of 4 divided by p times q to the power of 1. Oh, right, okay. So I can maybe cancel down. This becomes 64. It does. 5 64s is 320, except it's not writing. And look at this. The p's cancel. Good night. And what's q to the power of 4 divided by q to the power of 1? That's q to the power of 3. Oh, so q cubed is 64. And the cube root of 64, you know that. Well, that's 4. Oh, come on. Is that all right? The cube root of 64 is 4. Well, if I know that q is now 4, I can go back to him and work out p. I think I will. So 5 equals P times 4, and then just divide by 4. It won't let me do a 4. How do you do a 4? There you go, 4. Divide by 4, P equals 5 over 4, otherwise known as 1 1/4. Not too bad, it works. Okay, I'm really hitting this thing quite hard. There we go. That's meant to say 1 over 4. Is that all right? That's a 4 and that's a 1. Beautiful. So they're the two bits and pieces. I'll just scroll back so you can see a slightly neater version up here, and then you can do it yourself. Again, I've set up two simultaneous equations, eliminated the P, got the Q, and once I've got the Q, I shoved it in here. So I let it sit there for a bit so you can pause it on the video. All right, I think that's all of it. Yeah, that is all of that. Now today's work, which is way easier than this, if I get rid of that, yeah, save it. No, I'll mess it up even more. Let's just go to this. This is today's stuff. It's probably a bit big. Let's just bring it down a little bit. Yeah, so remember, when I mark your work and I reattach and send it, please don't waste your time and money printing it off. Just make some corrections in green. Yeah, then surely we can demonstrate the fact that we've communicated. Now, thank you, Sam. You've done this. I think Tino was practically said that he'd done it because he says, "Shall I give it to you now? Shall I send it or what?" I said, "No, come to the lesson, Tino. We'll be fine." So this is easy. You just put 22.5 in your calculator and ask the calculator what the sign is, and do the same with all these numbers. And then, in fact, this is wrong. What is graph C? No, it's not graph C. What they're saying is, the graph is y equals sine x. So I just got upset with that. Then you do exactly the same with cosine. Ask your calculator what the cosine of 22.5 is, etc., etc., and then you get a lovely curve like that. This is the tricky one, but do the same for it anyway, and I'll show you how they're going to look. So all I'm asking to do is to do the last lot of graphs. There's no more graphs after this in terms of raw plotting. So that's that. I will move on to what's this next little bit here. Yeah, I will move on to this. However, your sine wave will look a bit like that. It will peak at 1 at 90 degrees, go down to 0 at 180 degrees, have a negative sign on 270, and 360 has a sine of 0. And so a single sine wave looks like that. You may be thinking of amplitude, frequency, science, physics. Well, it's a sine wave. Here it is. And so it will look like that. So don't go above 1 because it won't. Don't force it to go up to 4 just because the scale says 4 on it. Your sine wave will look like that. Your cosine wave will look like that. And your tangent will look like that. I've rubbed off little arrows up here. What this means is that this goes up forever and ever and ever and ever and ever and goes off the top of the laptop. It will forever approach 90 degrees but will never actually touch it. It's this A word again, asymptote. Just above 90, 90.000000000, more noughts, 1. And if you work out his tan, it comes back here from minus infinity, getting further and further and further and further away to eventually hit 80, 180, and the tangent 180 is 0. Then it starts to climb towards 270 again, closer and closer and closer, but never actually touches because it's an asymptote. That's an A-level word, like I said. Yeah, that is what tan x looks like. They never touch, so I know some of you are going to do this because you're really not listening. You're going to join that bit to that bit, like it's like ziggy-zaggy. No, it's not. This is not like, heartbeats and stuff like that. It's not that. That goes towards infinity in the positive direction. This comes from infinity in the negative direction. This goes towards infinity, towards 270 degrees, but won't never touch it, etc. Now, I'm not going to waste this opportunity to introduce a little bit of something we're going to have to learn in year 11. Try not to crash. It says it's not responding. Right, that's tomorrow's lesson. Ignore that. Here we are. Here's a question I have for you. I know the answer to this because I memorized it as a kid. Here's a line facility. What's that? Here's the line facility. Oh, that's the line facility, is it? Okay, good. Here's a line. Would somebody like to tell me what the equation of that line is? Anybody know? Come on, Hamza, you're the best speaker. What's the equation of that line? Yeah, it's y equals 0.5, so I'm going to write it down. Y equals a half. If y equals a half and y equals sine x, I've just said find the angle when sine x equals a half. So I can talk to my calculator, put in 0.5 and ask it using should sine what the angle is. Don't waste your time, I'm going to tell you now. Back to my line facility. There's an answer, and I promise you the answer is 30 degrees. The answer is 30 degrees. Because I remember as a kid, 30 degrees has a sine of 0.5. Can you see anywhere else where there is an answer for the angle where the sine is also 0.5? Any ideas? Let me draw it in for you if you can't see it. Here's the line facility, right there. Can anyone intelligently tell me what angle that is? 150, 160. It is exactly 150. And I'll tell you why it's exactly 150. I'm trying to keep it out of the way. It is exactly 150 degrees. Again, this is year 11 work, higher trigonometry. Do you see, because this graph has perfect symmetry there and perfect symmetry there, you can use the symmetry of the graph to work out solutions. The first one, you've obviously got to ask your calculator about. And the first solution is 30 degrees. That 30 degrees is coming from 0 in that direction. But to track back the symmetry, I need to go back 30 degrees from 180. And of course, 180 take away 30 is 150 degrees. If you was to put your calculator sin 30 equals, you get 0.5. If you were to put in your calculator sin 150 degrees equals, you get 0.5. Don't be surprised by that, because there are such things as obtuse angles, and obtuse angles can have the same sign as their acute counterpart. These two guys are friends. These two guys are... But I don't want to talk about that anymore, because this is for year 11. But bear in mind, this is going to go on YouTube sometime this afternoon. I wanted to flag it now. And you can play symmetry games with cosine. It's a lot harder with tangent. There's other ways that I do work tangent with tangent. So that's got a beautiful symmetry. It really has. I mean, it's even easier than that one, because it's all on the, you know, down, up and round again. So could do one more, but we won't do that. But so the work, that's tomorrow's lesson, the work is just draw the 3 graphs, show me it, and I just say thanks for showing me it. Then I know at least you've got it and you can appreciate the shape. This is all going somewhere. All of this is required for tomorrow's major lesson, which is big. I've already uploaded the sheets, I think. Don't even touch that until the lesson. It's not something you can just do. You've had no teaching on it, and there's no year 9 work you can draw on. You just can't do it. You need to be here tomorrow. So if you come back